Hi everyone, welcome to our newest episode of the CATIA System Talks. My name is Honorata Frinks, and our topic today is incorporating cybersecurity into system modeling with DDS, SysML, and CATIA Magic Cyber-Systems Engineer. This webinar will unveil a first-of-a-kind security plugin for CATIA Magic that enables fine-grained configuration of data-centric cybersecurity controls to be directly incorporated into your SysML models. My guests today are our partners from Inquiry Labs PLC with its Director of Solutions, MBSE, Peter Lung. Hi, Peter. And Hila Abraham, Senior Research Engineer at Real Time Innovations. Welcome, Hila.
Hello.
After the presentation, we will have a Q&A session. You can already type in your questions into the comment field and we will answer them later on. And now I hand over to my guest, Peter Hila. The stage is.
Thank you for the introduction. Hello, everybody, and thank you very much for joining us today. As mentioned, my name is Hila Ben Abraham. I'm with RTI, and I'm really thrilled to have Peter Lung from Inquiry Labs presenting with me today. Before we get started on our topic, I'd like to pose a few questions for you. When you consider your distributed system, can you say if the cybersecurity configuration of the system is visible in the model? Is it visible in your system? Is it verifiable? Is it traceable? In our presentation today, we're going to explain and demonstrate how we extended MBSC, model-based system engineering, so it can be used to answer yes to all of these questions. We've got an informative session planned, so let's get started. To begin, I'd like to share just a few details about RTI. RTI is the leading vendor of products compliant with the Object Management Group Data Distribution Service Standard. This standard is usually referred to as DDS, and I will give a brief overview of it in just a few moments. RTI's software product is called RTI Connect, and it is the leading DDS-based communication framework for real-time systems. It is used in many industries. To give just a few examples, our software runs in over 250 autonomous vehicle programs. It controls the largest power plant in North America. It coordinates combat management on US Navy ships, and it drives a new generation of medical robotics and provides 24/7 intelligence for hospital and emergency medicine. In addition to being in so many operational systems, RTI also actively engages in government-funded research. The goal of the research team is to solve challenges in complex distributed systems that are broadly relevant to our customers. For example, the work that we present here today is an outcome of government-funded research that was conducted by the RTI research team. One last thing to keep in mind is that we have global presence, including North America headquarters in California, European headquarters in Spain, and an office in Singapore. Sorry, I clicked the slide just a second too early. But with that, I'd like to pass the mic over to Peter so he can introduce Inquiry Labs. Peter?
All right, thanks, Hila. Hello, everyone. My name is Peter Lung. I'm the Director of Solutions for MBSE Services at Inquiry Group. We're a specialist company and a long-tenured partner of the SAW. Our company's main portfolio consists of providing quality and key engineering services in the safety-critical domain, mainly specializing in MBSE and systems engineering. We have been working with a very wide range of fields and customers in various domains of engineering, going all the way from aerospace to various mobility vendors, industrial automation, and engineering tool vendors as well. This includes naturally RTI, one of our most valuable partners, who we have been collaborating on this project with. In addition to this, it's important to note that we have offices in Budapest, Vienna, and Denver, and have presence on 3 main continents.
Okay, thank you, Peter.
Thank you very much.
So let's dive into some details now and discuss how we created a new Cameo plugin to support the security modeling of distributed data-centric networks. And let's just start by with a brief overview of what DDS is and how the unique data-centric characteristics of DDS really enable us to introduce new ways to secure and model distributed systems. So the DDS standard is a pretty long standard, is a very comprehensive standard. But today I put a 101 slide just to give everyone the background that they need to be able to follow our presentation. So first, consider that DDS is a publisher-subscriber communication standard. The communication mechanisms of DDS are implemented by the middleware, and the middleware is responsible to support the scalability, reliability, and all the real-time performance requirements of the system. The first thing to remember about DDS is that applications, also known as domain participants, communicate with each other in the DDS network by subscribing or publishing data with a predefined name and structure. We call this predefined name and structure a topic. And a topic can really be anything. It can be a temperature read published by a sensor. It can be a command published by a controller, or it can also be a frame of a video stream published by a video card. We'll see a couple of examples in the demo today. The second thing to remember is that the second concept to remember is a DDS domain. The DDS domain can be viewed as a logical network partition, and we use DDS domain to basically group applications together for performance reasons and for security reasons. This allows us more efficient and secure way to exchange information between the applications. So one of the values of the DDS standard is data centricity. The DDS standard is not just a pipe for exchanging data. It's really a data bus which application can use to share information with each other. Given the data centricity, that it is data-centric, given the data centricity property, traditional security solutions, which really focus on securing the communication between two endpoints, do not really work well with these many-to-many communication patterns, where an application can subscribe to get a piece of data, a specific topic, without knowing if there is a publisher in the system, and with the capability to come and go whenever it wants. And a publisher can really publish samples of a topic without knowing how many subscribers are there, and if they come and go, and at what point they're active. So as I said, this is a many-to-many communication pattern that cannot be just secured by creating kind of a security around the tunnel. This is not end-to-end communication. This is many-to-many communication. So therefore, the DDS security standard takes a different approach. First, all the DDS applications are authenticated when they first join a domain, when they first join a network. But it doesn't really end with participant authentication, because the DDS middleware also enforces access control rules to make sure that participants are authorized to either publish or subscribe to specific topics. And so this fine-grained access control capability is configurable and allows the middleware at any point in time to figure out if an application is allowed to write this piece of information or to read this piece of information, not to generally read or write to the database, but really fine-grained control per topic. In addition to that, the DDS also maintains data integrity, confidentiality, and authenticity, and they can be configured for the entire network partition, so all the communication exchange within the network, or per data type. So for instance, we can define that some topics, some data samples are going to be encrypted, while others are only going to be authenticated. And all of this is implemented by the middleware, not by the application. So it really decouples the complexity from the application. And this is all, as I said, configurable. And we're going to use this property, basically, that we have security configurable as part of the as one of the enablers of data security modeling. We'll show it in the demo. So one last thing as piece of background information is that the data-centric capabilities I mentioned really changed the way we model network communications. Instead of focusing on data flows, instead of trying to identify in advance all the data flows that are going to be in the system, which is not a piece of information that is always known during modeling time. Instead of doing that, we're going to model the security of data. We're going to create trust boundaries around the data. And generally speaking, we have two different trust boundaries. We model outsider threats by creating a trust boundary around the entire domain. Basically, that means that all the mitigations that are going to be modeled are going to apply to all the domain communication. And the second trust boundary that we create is used to model insider threats. So basically, all the mitigations are going to apply just for the specific topic communication, regardless of how many publishers or subscribers it has. So remember the question that we started with, or the questions that we started with: is your cybersecurity configuration visible in the model and your system? Is it verifiable? Is it traceable? These are really the goals that we're trying to achieve with this new Cameo plugin that we created. So today's challenges is that security is really an afterthought. In traditional networks that are not data-centric networks, it is hard to know all the data flows that are going to be deployed in the later on in the runtime system. It's hard to know them in advance. And typically, security is an afterthought. We want to address that. We want to integrate security early on in the process. The fact that security is an afterthought does not align well with the DevSecOps approach, because it supports minimal automation, and sometimes it requires manual configuration of security files, which is an error-prone process. In addition, it is really hard to validate the security control of a large-scale distributed system. It is hard to look at a large-scale distributed system and say, is the security posture of my system correct? Is it what it was intended to be? Can I get all the configuration file and figure out the how it is operating, basically? We're going to try and address this. As I said, we're going to use the model or this extension, MBSE extension we created to integrate security early on. We're going to incorporate high levels of automation by auto-generation of validate security artifacts directly from the model. And we're going to provide end-to-end security requirements traceability from the earliest stages through the design and deployment lifecycle. We're going to show it in the demo. And with that, I will hand it over to Peter, who will share some more information about the plugin and how we envision its architecture in action. Peter?
Thank you very much, Sheila. I'm going to start off with a bit of a problem statement definition and try to focus on what are the key pain points that we want to address with the plugin. And naturally, since it involves systems engineering and various other fields, it's going to start with the silo effect. As Sheila previously mentioned, currently security and communications design is sort of a separate field to systems engineering in many organizations. And this obviously leads to the dreaded silo effect, where all of these organizations are working in relative independence from each other, and they share very little information. This results in a situation where traceability becomes very difficult to manage between these artifacts. There's also a fair deal of duplication of information across a lot of these departments, with a very little as far as model reuse is considered. And naturally, the creation of the artifacts that are going to be necessary for the DDS runtime to utilize becomes a cumbersome manual operation that needs to be worked on by many different stakeholders. Like, for example, that you can see on the slides, we have different security experts, DDS experts, and systems engineers operating on a set of resources that have very little reuse among each other and very little in the way of interconnectivity and traceability. So in order to resolve this, Next slide, please. So in order to, thank you. So in order to resolve this, we suggest to essentially establish a completely new authoritative source of truth for information that is related to DDS security, obviously DDS communication design and systems engineering as well. And we chose this authoritative source of truth to be Cameo Systems Modeler, CATIA Magic, since it already includes the best of the breed systems engineering solution, a SysML solution on the market. And with the real-time communication designer plugin, it already has the capability to define DDS communication in the form of a Cameo plugin. And we essentially added a new extension to the tool in the form of the DDS security plugin, which depends and works together with the real-time communication designer plugin and Cameo's built-in SysML capabilities to be able to define DDS security concepts that are truly interconnected with all of the existing systems engineering models and the DDS models that the organization is working on. Naturally, this also includes the generative capabilities of the real-time communication designer plugin as well. So based on the model contents, the user is able to generate DDS communication models. And with the DDS security plugin, the user is also capable to produce all of the necessary auxiliary documents that are going to be important for ensuring security. Okay, so on the next slide, obviously, it's not enough to have just a plugin and just the capabilities to produce all of these necessary artifacts. You need sort of a workflow and the process to be able to produce them. And to that, we introduced the 6-step process of defining DDS security in Cameo Systems Modeler. As a first step, obviously, we need to capture DDS security constructs, and we basically need to import and define DDS security policies. Hila is going to explain this in in a lot of detail during the demo phase. Essentially, these security policies are responsible for defining the level of security associated with individual DDS artifacts. Once the policies are added to the model, we are able to assign these policies to certain DDS concepts. We obviously need to have a way to visualize the security aspects of the model. Naturally, since we're talking about MBSE and systems engineering, validating the content is one of the biggest values that we can get out of having these pieces of information in Cameo. And once we have a validated and complete model, we have the option to generate the security artifacts together with the DDS communication model. And once we have the process defined, we can essentially go over to the demo, where we are going to be able to show you the detailed workings of this plugin.
Okay. Let me just switch the screen here. There we go. Peter, can you see it?
I think thank you. I'm back. Yes, I can see it. Thank you very much. So I'm going to start with a very quick introduction on what you can see and what is the environment that we're operating in. So this is CATIA Systems Modeler 2021X. It has the real-time communication designer plugin installed. Just a reminder, this is a commercially available product of Dassault. And it also has the DDS security plugin installed, which is a non-commercial preview plugin at this point. Just to get oriented and get started on what you can do with this plugin. Essentially, these plugins allow you to extend existing SysML models with DDS concepts and DDS security concepts. With this, we are basically utilizing predefined profiles for essentially annotating existing SysML models with these DDS concepts. The two main packages that are going to be the main points of focus in this example, on the very left, you can see there's a DDS package and there's a DDS security policies package right there in the model root. So these are going to be holding the main pieces of information that is going to be necessary for this demo. And the DDS package contains all of the information that is captured via the real-time communication designer plugin. So all of the DDS domains, topics, data types that are going to be flowing over our system, all of the domain participants, all of the data readers, data writers that are going to be doing the data reading and data writing. And as this and as the security and in DDS security policies package, we are going to be able to define all of the security aspects that are we going to be able to assign to the individual DDS concepts. And now that we know like how the model looks like, what's the general structure, what are the installed plugins in the environment, I'd like to hand over the mic to Hila to actually show you how the security assignments are performed in CAMIO.
Okay, thank you, Peter. So in this model example, we have a simple model of a smart home. This model consists of a few applications here. You can see, I hope you can read it. I know that CAMIO screen can be, the text can be very small, but we basically have a home climate controller application here with some readers and writers. We have an AC unit here. We have a dehumidifier application modeled here. We have security camera and security display, and we have a lock controller and a lock keypad. And so for the purpose of the demo, we predefined a couple of security requirements that we are going to demonstrate how we can satisfy today and how they can be added to the model, visualized, and validated in order to auto-generate the associated configuration files with that are required, that satisfy those requirements. So there are three requirements that we defined here are, we want to mitigate outside spoofing. Basically, this means that we want to prevent an outsider from spoofing home sensors. The second requirement here is that we want to protect the confidentiality of the door lock. That means that we want to prevent others, legit and non-legit applications. This really implies that we want to create this trust boundary for both outsider and insider. We want to prevent all these others from sniffing the door code. So no one can basically read the door code, the passcode that we use to open the door. The third requirement that we defined here is mitigate tampering of camera alerts. The goal of this policy is to prevent others, again, legit and non-legit applications, from modifying camera alerts. And again, this legit and non-legit application really means that this level of protection is required for a topic, not for all the applications. Because some applications can be legit, but we still want to prevent those legit applications from tampering the topic data, specifically the camera alerts in our example. So to start, I'm going to go to the domain security policies. And in this table, I can basically create new policies. I can craft them from scratch, basically. I can create a name, a description, and really define all the DDS security properties that would create the behavior of the policy, that would create the behavior that is going to be read by the middleware to create the security mitigation needed. In this example, to save some time, I'm not going to basically create security policies from scratch, but instead, I'm going to import them. So to import security policies, I'm going to go to Tools, DDS, Security, and I'm going to click Import RTI Policies file. Here, I'm going to tell CAMIO where my policy file is. And in this example, I created before this demo an XML that consists of all the security policies needed for this smart home model. And I can click Open after choosing this file. So CAMIO now can import those policies. And I'm going to tell CAMIO where the package is. So I'm going to add them to the DDS security policies package here. And I'm going to hit Finish. And here what you can see is that two policies were added. The first one is mitigate outsider spoofing. It has a description and it has all the properties associated, the DDS properties, the very specific DDS properties associated or included in this policy. And then we have a second policy here, which is encrypt all domain communication. There's description and also a set of properties. Now, an interesting thing to pay attention to is this last column. The last column is Stride as domain outsider. So basically, to be able to create or understand the details or the specifics of how RTI technology, how our middleware can create those mitigations, can actually prevent outsider spoofing, you kind of need to understand DDS security and become an expert. To simplify the process, we created this level of abstraction that can translate the DDS security policy into a Stride policy, and or translate it to what it really means in the Stride language. And for those of you who don't know, Stride is a threat modeling methodology that stands for spoofing, tampering, non-repudiation, information disclosure, denial of service, and elevation of privileges. These are what the letters stand for. And in this simple example, you can see that the first policy that we imported can mitigate spoofing, tampering, denial of service, and elevation of privileges. And then the second one can mitigate the same threats, but it can also mitigate information disclosure. It can also support information disclosure requirements, because this one really encrypts the traffic. And so this mapping is dynamic. So if I change encrypt, for instance, to be sign, right now, you see that the I went away. So this is just one thing to keep in mind, that we created this additional abstraction to really map DDS security language into the Stride language. So the XML, going back to the XML that I imported, it has these two policies that I showed here. And in addition, it has two topic policies that were added to the topic policies table. Now, at this point, what I'm going to do is I'm going to assign the policies that I imported, and I'm going to assign them to the DDS concept that basically satisfy the security requirements that I defined here. So let's start. Let's look at the mitigate outside spoofing. So to satisfy this requirement, I will go to my domain security policy assignment table, and I will create an assignment now that will basically say, well, let's take the domain policy, the mitigate outsider spoofing domain policy, and assign it to the domain, to this logical network partition that we're modeling here. In our example, we only have one one domain, so all the applications are running on the same domain. But you can imagine that we could have multiple domains, multiple partitions of our network, and then we would have a list of domains here. So for our example, we want to mitigate outsider spoofing. So we want to create this trust boundary for all the communication within the model. We created the assignment. You can see the Stride column here again, just to remind us what it really means, what this assignment really means in the Stride language. And right now, I'm just going to give this assignment a name so it will be easier for me to really link it to the requirement, to the security requirement. So in this one, I'm going to call it mitigate spoofing. I'm going to close this. And now I can go back to my security requirements and mark this security requirement as satisfied by the assignment that I just created. So I'm going back here, and I can see the mitigate spoofing assignment. So I'm adding it. And now I can trace the configuration, the specific assignment, and understand what security requirements it was meant to satisfy. Let's go to the next two security requirements. So as I mentioned before, those are really topic-specific requirements because those are related to specific data that is being exchanged, specifically protecting the confidentiality of the door code and mitigating the tampering of camera alerts. So what I'm going to do, I'm going to go to the topic assignment table. I'm going to create an assignment for each one of these topics with the right security policy. So let's see how we can do it. This is the topic security policy assignment table. And now I'm going to add the first security assignment. Here it is. So we said this is a topic assignment. So now I'm going to say, okay, I need to encrypt a log code. I actually created a policy for this specific requirement in the XML that I imported. I'm going to click this. I'm going to choose the context, which is, again, the domain. We only have one. And I'm going to assign this encrypt log code policy to the log command topic, which is really the data structure that carries the passcode used to unlock and lock the door. So once I hit this, I can give this assignment a name, and let's call it mitigate, let's say, information disclosure. Okay. And I think I have a typo there, but it's okay. And now let's create the other. Remember, we had two topic requirements here. So I'm just going to quickly add the second. I'm going to quickly create this additional assignment, which is mitigate inside tampering of topic data. And I'm going to assign it to my camera alert topic. So again, choosing the right context here, and then going with the motion detected topic, which is again the structure that really carries the motion, the camera alerts. So I'm going to give this a name as well, so it will be easier for me. And now I'm going to call it mitigate tampering. I'm going to go back to my security requirements here. And now I can mark these two requirements satisfied by the security assignment that I created. So the first one is the mitigate information disclosure. I have a typo here. Okay. And then this third one is mitigate tampering of camera alerts. So this is the assignment that I created. Okay. So at this point, I satisfied all the requirements. Let's move on and show the other parts of the Cameo plugin, the visualization, validation, and auto-generation of the security configuration files that are going to basically inherit this assignment and generate files ready to be deployed and read by our middleware. So with that, I'm going to go back to my model here. And I'm going to create the security model, the overlay security model, and visualize it on top of this system model, this very simple model example. So to do that, I'm going to go to Tools, DDS, Security, and I'm going to click Generate Legend for the security model. When I do that, Cameo is going to ask me where to take the policy assignments from. I'm going to click the DDS security policies folder here. And it's going to ask me where to output the legend to. In our example, I'm just going to output it to the same folder. So this DDS security policies folder. So once I hit finish, we should see the legend created here underneath the overview. I'm going to click finish and OK. And you can see this new security model IBD legend created. At this point, I'm going to drag the legend into my model, into this IBD diagram. And then in a few seconds, what you can see here is that Cameo, the colors of the DDS concepts in my model changed. First, I want to remind everyone that the first assignment that I created was a domain level assignment, meaning that it is going to create some mitigation mechanisms for all the communication within the model. So in our example, we only have one domain. I'm sorry, all the communication in the domain. So in our example, we only have one domain. So all the application changed their colors because they're all going to be affected by this assignment. And you can see that the color really indicates that those participants are going to be protected against outsider spoofing. The two other assignments that I created can be shown here by the color and the style of the lines. I don't know if everyone can see it, so I'm just going to make it a little bit more visible. I'm going to click the encrypt log code line here, or security assignment here, and I'm just going to change its style real quick to show that we can also configure the colors and style of the model, the way that we visualize it, to make it clear to anyone looking at the model what security policies and what security assignments were created for this model. So I'm just going to make the line a little bit wider, and now I'm going to hit OK. And hopefully you can now see that this turned red. You can put symbols in it. You can change the style of the line. You can do whatever you want. And then now you can see that in addition to having all the participants, all these applications protected against outsider spoofing, this specific topic, the one in red, is also going to encrypt the information being exchanged by this topic. So this is actually going to satisfy the confidentiality requirement for the door lock that I showed before. And then the second color that you see here is the mitigate insider tampering of topic data. And you can see hopefully that it is dotted and it is in kind of dark blue here. So this is how we can visualize the overlay security model on top of the existing DDS model. Now, I can look at that and I can immediately see what is encrypted, what is mitigated, what information is going to be shared, and what is going to be protected against tampering, and what is going to be protected against spoofing. This is easily visible from this color. Now, assuming that I'm happy with my security model, I can now validate it. And so to validate the security model, I'm going to go to Analyze, Validation, and I'm going to click Validate. And here I'm going to choose the DDS Security Validation Suite, which is an extensible suite that we created as part of this plugin. So basically, we created an initial set of rules that looks at all the policies and all the correlation between the different policy assignments and tell us what is the security posture of the system, kind of in high level, right? And we can extend this validation suite to include rules that are specific to your system. So we intentionally created these to be extensible. So once I choose the DDS Security Validation Suite here and I click Validate, Cameo is going to go over all the policies that I imported or created and the policy assignments that I created. And it's going to notify me information based on the rules created in this validation suite. So in this example, I got 3 info messages here. So let's first take a look at the bottom, the 2 bottom ones. So basically, these 2 info messages tell me that there is some redundant protection here. We're having redundant protection of liveliness information and discovery information. And this is actually true. This is something that I configured as in the policies of these, the policies that I used for this topic, because in practice, what's going to happen is that the middleware is going to create 2 different mechanisms to basically protect all the information, all the data exchanged in the domain, and then another trust boundary around the topic. So it is going to basically sign different parts of the RTPS packet twice. This is okay. This is by design, so I'm good with that. It is good to know, though, because if this presents any performance issues, then I would want to consider that and maybe change the policy. But in our example, this is okay. This is just Cameo way to tell me, just keep in mind that you may have an issue here, maybe a performance issue, but this was intended, so this is okay. The first information message that we got here is a really interesting one. So basically, it tells me topic is encrypted, but a domain insider may be exposed to liveliness and discovery information. In security language, this really means that we may be exposed to side channel attacks, because someone sniffs the traffic, it can see liveliness and discovery information being exchanged, and it may carry the topic name. If we want to make sure that we're protected against side channel attacks, we can take the recommendation here. If this presents a risk, consider moving the topic to an encrypted domain. In our specific example, it doesn't really matter because anyone looking at my door can see that I have a smart lock. So maybe I'm not really worried about side channel attacks. So in our specific example, I'm not going to do anything about it, but it is very possible that in your systems, you have sensitive topics that you want to protect against side channel attacks. So this information could be very helpful for you because maybe you didn't realize it before. And now you can actually take actions and protect this sensitive topic in side channel attacks. So again, in our example, we're good. Those are only info messages, so and they don't require any change to our system. So I'm happy with my security model. And at this point, I'm going to basically generate the security artifact outside from this model. So what I'm going to do now is I'm going to go to Tools, DDS, Security, and I have two export options here. I can export the governance file and I can export the permissions file. And these two files have different purposes. They're used by our middleware to basically create the confidentiality, authenticity, and integrity mechanisms for the domain or the data samples being exchanged. And the permissions file specifically is used to basically create all the access control configuration that is going to be checked by the middleware every time that an application sends the sample. So without going into all the details of those files, what I'm going to do is I'm just going to generate them. So I'm going to click Export Governance File here. I'm going to tell Cameo where to take the security policies and the policy assignments. I'm going to choose the DDS Security Policies folder. I'm going to hit Next. Cameo is going to run the new plugin that we created is going to run validation again because we don't want to auto-generate misconfigurations. We don't want to auto-generate configuration files, specifically security configuration files that did not pass validation, because those configuration files are going to be taken and deployed in the real-time system. So we want to make sure that they're correct. So in our example, we passed validation. So the status is okay, and we can continue to generate the files. But if I had errors or warnings, then the Cameo plugin would tell me error or warning, go back, fix the assignments, fix the policies before you can generate the configuration files. So this is kind of another way to make sure, and another mechanism that we added to the plugin to make sure that we can streamline the auto generation of validated configuration files. So I'm going to hit Next here, and I'm going to tell Cameo where to output my configuration files to. So here I'm just going to create a new folder. So I'm going to call it Output. And I'm going to give this specific output a name. So I'm going to call it governance.xml. And I'm going to save, finish. And if I bring my folder here, I can see this newly created folder, this output folder, and the governance file that was created. And now I can quickly go and basically auto-generate all the access control, the permissions files. I'm going to hit this, and I'm going to tell Cameo where to take all the DDS concepts from. I'm going to hit Next. And here I'm going to give Cameo the same folder here, so the same output folder. I'm going to hit Open, Finish. And if I bring back this folder, now I can see that Cameo created an XML file, a permissions file, access control configuration for each one of the applications that I have in the model. This is basically the demo that we have for you today. Let me go switch back to the slides to just summarize and leave some time for questions.
Thanks a lot. That was very interesting and going in deep. So if you have any questions, you can type them into the comment field and we will answer them accordingly, at least a few. And if you have a few questions that come up later on, you can also join our community, which you can find here. And then Peter and Hila will answer your questions right in the community. So, okay. I think we have a few questions coming from the community, actually. So I will read them. Is the plugin available to use and how can we get it?
So I can answer this. The plugin right now is available for evaluation. If you want to use it, please reach out to research@rti.com and we'll be happy to discuss and give you the plugin for evaluation. Just keep in mind that you will also need the DDS plugin. I believe you can get a trial version from the 3DS website.
Thanks a lot. And what other files can be generated from the model?
Okay. So I showed you how we can generate the governance XML and the permission files, XML, all the XML files that are required for the security configuration for the middleware to read and apply the correct security mechanisms. But in addition to that, the original DDS plugin can generate the DDS model itself, meaning the XML file that defines all the DDS concepts, all the domain participants, all the data types, all the topics, publisher, subscriber, etc. So all of it can also be generated from the original DDS.
Thanks a lot. We have another question in the community. Why were instance specifications used for policies as opposed to other element types?
Could you give example for element types?
I know
or I
what
don't know
is.
if
I know.
Peter
I can take this one.
answer
I
it?
can take
Okay.
this one, Hila. I can take this one. The main reason why we used instance specification, I didn't want to go into this much detail about the technical aspects of the plugin, but it's always nice to have these in-depth questions. So essentially how the plugin works, that it has a completely generic import and export feature, which means that we essentially have the ability to import and export the XML schema for the for the policy definitions themselves. And in order to do that, we actually use the type level elements of UML and SysML to represent the schema of the policies. And in order to be able to create instances of this type level structure, we needed to use instance specification level elements to actually represent the instances for the policies.
Thanks a lot. And this question was coming from Sean, and Sean has another question. Is there an override for the validation on the report generation?
There is not. The best way to override it is to actually customize the validation rules. So there is one way to, change the severity of certain types of validation rules. It's actually every user in Cameo can do that. Currently, the logic works in a way that if there is errors in the models, it will just simply prevent you from executing the export. I believe warnings are still fine, and obviously information level severity items are also fine from the export's perspective. But the reason why we have this is that error severity rules are really problematic from an export. So actually, it will not produce a valid output if you have errors in the model in the current configuration of the plugin. So it will either produce bogus output, or it will completely just break the transformation itself during the export mechanism. So it's the error severity rules are errors for a reason.
Thanks a lot. I think we have to stop now. We are pretty much over time now. But if you have any additional questions, I invite you to join the community. You see it there, go3ds.com/cyber.systems, and you will find our post here with a replay of this CATIA system talk, and you can ask questions to Hila and Peter right in the chat of this post in the community. Thanks a lot for being my guests today and sharing all this great knowledge with us. And I hope to see you soon. And goodbye. Till next time.
Thanks. Goodbye.
Bye.
Bye-bye.